Relationships involving heat of reaction. So the heat of reaction is an extensive property, meaning it depends on how much stuff there is. So if the reaction changes, delta H is also going to change. So these are some rules for if you do something to an equation, what do you do to delta H? So if you multiply the chemical equation by a factor, then you multiply delta H by the same factor. So here we have this chemical reaction, and it's got a delta H. What we've done down here is we've multiplied all the coefficients by 2. We're using twice as much stuff. So then the energy change should be twice as much, right? So we're multiplying this by 2. If we reverse the equation, the sign changes. So if going from A and B to C gives us, say, positive 50 kilojoules, then going backwards must be negative 50, right? You can't create or destroy energy just by going back and forth. It'd be great if you could, but you can't. So you switch the order, swap reactants and products, you change the sign. And then this is Hess's law. So delta H is a state function. It doesn't matter how you get there. So we can actually do a pretty good estimation of delta H for a reaction without doing the reaction if we look up some information that other people have done. So if we can find some other chemical reactions that we can add together to get the reaction that we want, then we can just add up the delta H's and get delta H for the reaction that we want. So the idea here, we're looking at A plus 2B goes to D. So we're trying to find this purple arrow. We don't know what that is. But from other experiments, we know that if you go from A and 2B up to C, we're going to go up this much, and then from C to 2D, we're going to go down that much, right? So that's positive and this is negative, and we add them together, we're going to get the purple one, okay? So we can find delta H for reactions that are really hard to measure in the lab. I kind of already said that. So here's a simple example. 2A plus B goes to C. For that chemical reaction, delta H is 122 joules. So what if we do 2C goes to 4A plus 2B? What we want to do here is look at how is this equation different than that one. There's two differences. It's reversed, right? Here, C was a product, and here, C is the reactant. So if we're reversing it, then what do we do to delta H?
Reverse the sign.
We change the sign. So it was positive, now it's negative. What else is different? What was the coefficient here? And what's the coefficient here? They were all doubled. So then we're going to double delta H also. And so 2 times 122, we should be able to do that in our heads, minus 244. So we're going to do this example, and then there's another example that we're going to save for next week, and we'll call that reviewing Hess's law. Yeah, that's what we'll do. Okay. Problems like this do show up on exams in Chem 1A, and in Chem 1B you need this stuff too. So, how do you do this? I've tried explaining this different ways, and I think I've come, well, this is the best method I've come to so far. So before we get started, let's just do some color coding, right? So this guy, N2O gas, I'm going to highlight in yellow. And then they're giving us these reactions, and because this is a setup problem, we're going to need all of them, and we're not going to need anything else. But I'm going to go and look for N2O gas in these equations. So it's right there. And then I'm going to make NO2 a different color. Maybe that one's green. And I'm going to find that in these equations. There's NO2. That's the only place. And then we've got no. And there's no here. And there's no there. You see what I did? I'm just making it easier to look at because all of these are NO. It's just a difference in how many N's and how many O's, and it's so easy to get them all mixed up. So I'm just going to give them colors. What I want to do now is I want to look at this, and I'm going to try to take these and put them together so I get the right colors on the right sides. So this one has N2O as a reactant. So this is the only one that has N2O. Here it is as a reactant. So I'm going to write this equation down in the same direction. So 2N2O gas going to 2N2 plus O2. And then I'm going to write down what delta H is. I didn't do anything to this equation yet, so I don't have to do anything to delta H. So that's N2O. Is this the right coefficient for my final equation? No. This is a 2. This should have a 1. So I'm going to take this equation and divide all the coefficients by 2. So dividing by 2, that's going to be a 1. This is going to be a 1. This was 1, but I'm dividing by 2, so now it's a half. And then I'm going to divide this by 2. Negative 163.2 divided by 2. Negative 81.6 kilojoules. Does that make sense? I'm using half as much in my reaction, and so the energy changes half as much. I'm going to look for the green one. Here's the green one. But this has it as a product, and I want it as a reactant. So I need to write that one reversed. I'm going to try to keep my arrows lined up. So here I have 2NO2 gas making 2NO gas. That's the green one, and this one also happens to have the orange one in it. So what do I do to the delta H when I reverse it? I change the sign, right? So now this one is positive 113.1 kilojoules. It's like buying and selling is opposite, right? Is this the right coefficient for this? No. I need to divide by 2 again. So I'm going to divide this by 2, that makes that 1, and divide this by 2, and that makes that 1. And then I'm going to divide this by 2. 113.1 divided by 2. So this is 56.55 kilojoules. And that one's positive. Okay. So I have the right colored things on the right sides, but I also have some extra stuff in here, and I need that to go away. I also don't have the right coefficient on the NO because there's supposed to be 3 of them, and I only have 1. but these are all correct. So let's take, so we used that one, and we used that one. So we need to use this other one. So this one has NO, the orange one, on the product side, which is where the orange one belongs. So I'm going to write it down in the same direction. So this is N2 gas plus O2 gas, making 2 NO gas. Did I do anything to delta H? Well, did I do anything to the equation? I didn't. I wrote the equation the same way it was, so I write that the same way it was. So this is still plus 182.6 kilojoules. So if I go to add these guys up now, here I have 1 mole of nitrogen being produced, and here's 1 mole of nitrogen being used up. So those guys negate each other. And what did I forget?
O2.
I forgot the O2. So this guy, oops. See, the O2s aren't canceling out because I left something out. This guy had O2 as a product, and I skipped that. Forgot to write it down. So there's O2 as the product, and I had divided all of the coefficients by 2. Okay, now we can do something with this. So here I have O2, and here I have 1/2 plus 1/2. So these guys are going to cancel out with that guy. And when I write the whole thing down here, I'm going to get N2O gas plus NO2 gas going to, here I have 1 of these and another 2, that's 3. So I added those equations together. I'm going to add the delta H's together with the changes that I made to them. Negative 81.6 plus 56.55 plus 182.6 plus 157.55, and so that should be 157.6 kilojoules. You guys look just so sad. You just did all of this to us, and now you're going to give us an exam. I'm sorry.